Alright, now consider problem solving. We do have a trapezoid or a four-sided figure on this coordinate plane. I'm going to show you some shortcuts that you can use to get the coordinates after rotation by using a rule. So the first thing we want to do, we have a quadrilateral here with vertices D, E, F, and G, and we want to rotate this quadrilateral 90 degrees clockwise. Okay, so these are the coordinates of that quadrilateral written out here. After a 90 degrees clockwise rotation, what does D prime become? What does E prime become? What will be the coordinates of F prime? What will be the coordinates of G prime? Remember, the primes are the images after the rotation. The rotation rule is easy to identify. Let's start by rotating the paper 90 degrees clockwise. We rotate our paper 90 degrees clockwise. Now, there are so many coordinates, do not get overwhelmed. Track one coordinate. Let's deal with the coordinates of D right here. After the rotation, we have D sitting here in the first quadrant with a positive 1 for X coordinate and a positive 2 for Y coordinate. It says negative 2 here, but it is not negative 2, as we know that above 0 we always have positive numbers. So 1 for X, because this is on the right of 0, and 2 for Y. So we come over here and we see that after the rotation, D becomes 1 for X and positive 2 for Y. Now we are going to use the transformation that has occurred on these coordinates of D to get the rest of the coordinates. We don't necessarily have to go reading on the coordinate grid. So we can see the first thing that we observe is that the coordinates have switched position. So this one was Y coordinate, it is now X coordinate. So we can say that the rule here, we can make a rule that for any point with coordinates X, Y, after a 90 degrees clockwise rotation, the Y coordinate will come sit in the X coordinate position, and the X coordinate will go to the Y coordinate position, but it will change its sign. We see this negative 2 became a positive 2, so we're going to get a negative X right here, because this was a positive X, so it becomes a negative X. It just changes the sign, okay? So this number was negative, it changes the sign to a positive. So whatever number is here, it will change its sign. If it was a negative number, it will become positive. If it is a positive number, it becomes negative, okay? So with that rule in mind, now we can go ahead and write the rest of the transformations. E will become, we switch the 2. it will be 3, because this y will go to the position of x. It will be 3, and then it's supposed to be negative 0, but 0 absorbs a negative sign. 0 does not show whether it's negative or positive, it just stays 0. Okay, so it will be 3, 0. F prime will be, we have 5, 2 that will switch, but this 2 comes up, the y goes without changing sign, but the 5 goes to the back and changes sign to a negative. Okay, so these 2 will switch, the negative 2 will come up top, and the 3 will go to the back, but it will change the sign to a negative. Okay, so we can use that rule to determine the coordinates of a point when we do a rotation. If you don't want to use the rule, remember the coordinate grid is there. You can still go ahead and read the coordinates on the rotated figure. So that is how we use a shortcut to get a matrix of transformation. So now, if we have to draw, if we now to draw the image of this quadrilateral after the rotation, we need to keep our coordinate grid back in its original position and then plot all these coordinates. So let's get D prime. So D prime is 1, 2. So 1, 2, this is where D prime will be. E prime is 3, 0. So 3, 0, this is where E prime will be. F prime is 2, negative 5. So 2, negative 5, this is where F prime will be. And G prime is negative 2, negative 3. So this is where G prime will be at negative 2, negative 3. G prime. Okay, so if we were to draw the new figure after the 90 degrees clockwise rotation, this is what we will have. We connect D prime to E prime. We connect the vertices to get our new figure. So this figure that is in blue is what we get when we rotate that quadrilateral 90 degrees clockwise. So yeah, about the origin, if we rotate this 90 degrees clockwise, this is what it will be. Okay. And that is how we use the transformation rule to a transformation rule. So that is how we use the transformation rule for rotations to find the coordinates of rotation.